Yo, 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 Miggity Mic check 1, 2. What is this? Back with another one, another coding exercise, another Code Wars coding exercise. This is Ship of Theseus, a Code Wars exercise done in Python. Needed to get it all out there. Welcome back, folks. Ready to grind. So, let's check out the description. The Ship of Theseus is a classic philosophical thought experiment about identity over time. We're getting philosophical on you. Yeah. It asks, if every part of a ship is gradually replaced, one piece at a time, is it still the same ship in the end? Something to ponder there. Piece, kind of like the human body, right? Like it is said, like pieces of ourselves are regenerated over time, and after a certain span of time, like you don't have your original parts, like they've been regenerated. That's a very non-technical way to say it, but you're not the same person you were when you were 7 years old if you're a 40-year-old man, you know, like pieces have been kind of changed. Even though maybe your soul is the same, your body has changed, or the parts have been replaced. But anyway, let's get back into the coding exercise. Went on a tangent on you. This kata turns that idea into a simple validation problem. A ship is represented by a matrix of states, and when they say matrix, it's going to be really in Python, it's going to be a two-dimensional list of something. Maybe strings here. Yeah, it's strings, I think. I should know I did the problem, right? Let's center here. Each row shows the ship at a different moment in time. So each row of this two-dimensional list is the ship at a different moment in time. The ship is considered to remain the same only if between every two consecutive rows, exactly one part of the ship has changed. Really? What you're going to be getting is, I remember it now because I'm looking at it, you're going to get a two-dimensional list of strings. And really the thing is going to be, you're going to go row by row and see if only one element has changed between each row. And I know there's examples in the bottom, but I want to give you my example first. So like, actually we'll use the idea of numbers. I guess I'll make this a 3. So this is a matrix, you know, it's rows and columns. It's a table, and kind of like a two-dimensional list in Python. Well, the thing we're going to check here is if between each two rows only one element has changed in the row. So we have this first row 1, 2, 2, and then we have the next row 1, 2, 3. And yeah, one thing has changed, the last element has changed from a 2 to a 3. So this would qualify. That's what it's talking about. And we'll go further. The second row to the third row, 1, 2, 3 to 2, 2, 3. And again, only one element has changed. The first element with the 2, the 1 has changed to a 2. So this would qualify as being acceptable in the Ship of Theseus, because that's what this means. Between every two consecutive rows, exactly one part of the ship is changed. Wanted to explain this a little bit because this sentence by itself is a little, it can be left up to interpretation. We're going to see an example too later on, but just wanted to give y'all that little nugget there. And here are the rules for looking at this matrix, or this Python list of lists, or two-dimensional list. All rows have to have the same length, so that's going to be a check that we're going to make. All rows must be compared position by position. This really just means element by element. Between one row and the next, consecutive rows, exactly one element must be different. That's what I was showing you with my little drawing, where one element is different. And if one element is not different, or if more than one element is different, or no elements are different, it disqualifies. If any transition changes 0 elements or more than one element, this is really what I just said, the process is invalid. So we're checking to see really if this qualifies as the ship of Theseus thing, like between for every 2 rows, exactly one change needs to be made from row to row. If that's not the case, it's invalid. And this solution is going to return a true or false. True if it's valid, otherwise it's false. And here's another rule down here. If the matrix or list of lists has 0 or 1 row, I'm just going to return true. So that's just like a validation thing. So we've got a lot of rules here to set up, in addition to the base check, which is the checking for the exactly one change between each row. So now that you got it, let me show you my solution. And go into the training area. I'm going to pop it in there and explain it. And I'll expand this out. So this is what I got. Let's break down this code here. Alright, of course we got our function header, and then this kind of takes care of the first rule, or one of the easier rules. If the length of, well, let me backtrack here. Actually, I didn't explain something. Ship. This is going to be your matrix. It'll be your list of lists, or yeah. That's going to be your matrix. And if the length of the matrix, meaning really is the number of rows, if the number of rows is 0 or the number of rows is 1, we're going to return true because that's what the rule said. That's what one of the rules said. That's like an input validation type of thing. So now we start a loop where I'm going to loop from the second row to the end of the matrix. I'm starting at the second row, which would be element, or would be row 1. Starting at that row, because what I'm going to do is, for each row I focus on, I'm going to look at the row behind it, or the previous row, because we need to compare consecutive rows. That's how we got to do it. This row to the previous to see if exactly one change has been made. So I'm starting there. I could also start at row 0 and look ahead 1, but I've just settled into using this kind of looping when I'm doing the consecutive look type of thing. All right, so as we loop, if the current row length is not equal to the length of the previous, then we return false, because this is another one of the rules. The rows have to be the same length, the same number of elements in them. If you don't have the same number of elements, it's a disqualifier, so we return false. Next, I can make an integer variable called diffs, where I'm going to store the number of differences between each row. So what it is, I'm going to, like I said, compare the current row to the previous row, and I'm going to count the differences as I do it. I'm going to go element by element, actually, and count the differences. And that element by element counting it happens in a deeper or a nested a nested loop. And in this nested loop, I'm going to use the zip function where I'm going to really look at these rows element by element. So like, I'll pull up a matrix again and just a simple sample one, and I'll just do like consecutive numbers. Let me do one more row to illustrate this idea. What I'm going to do is this nested loop is really going to grab, it's going to look at 2 rows at a time. Let's envision that we're looking at these first 2 rows. And I'm going to use the zip function to grab an element of each row. Really corresponding elements, like elements with at the same place in each row. So like, if we were focusing on these 2 rows, X and Y initially, they would be 1 and 4. And then what I'm going to do is, I'm going to compare those elements, see if the element in row, I guess you could say row 0 is not equal to the element in row 1, I'm going to record a difference because they're different. And remember, we're looking for exactly 1 difference between the rows. So if I compare 1 and 4 and I see that they're different, I'm going to mark off or increase my counter of differences. And I got a conditional right here that says if the number of differences is greater than 1, I'm returning false, because as I do my looping, if I get a difference count greater than 1, that means the 2 rows have a greater number of different elements than 1, and that breaks the rule basically. It is not a ship of Theseus. That's what's going on there. X and Y will become elements, corresponding elements of the rows. And this is checking for the number of differences between the rows being 0. So if there's no difference between the rows, 2 rows consecutive, I'm returning false, because that is also breaking a rule of the ship of Theseus. And if I get through all of this, meaning really this for loop, if I get through this for loop without returning, it means I've got a valid ship of Theseus, and I'm going to return true. And that's it. There is your ship of Theseus algorithm in this case. Give this a quick run. Looks good. Attempt. Looks good. We got it there. Excelente. So let's do this. There's another solution for you. So this is Ship of Theseus, Python, Code Wars. Ready to get started, ready to go. Show me your solution. And with that one, I am out.